Alright, now we get to a video where we compare the different fields. And a lot of people are so used to gravitational fields, and when they get to electrical fields they get a bit confused, but they're very, very similar. So let's have a look at them. We know that both of these are fields that act at a distance. Okay, they're non-contact fields. But how does it vary with distance? Well, if you remember that G, right, the gravitational field strength, varies according to the universal gravitation constant. Then we have the mass of the planet and then r squared. And so we have an inverse relationship. So we can even do that over here. I'm going to be writing out my face, but you know, it's an inverse square relationship. Well, so does the electric field strength. So the electric field strength, right, we could put arrows above those because they're both vectors, varies with K, right, which is the electrical permeability of free space constant. And then we have Q, the charge that we're talking about, over r squared. So as you can see, we've got equivalent expressions. Then what about forces between objects? What about the gravitational force between two objects? Well, Newton's universal law of gravitation is where we have G, and we have m1, m2 over r squared. So once again, we have that familiar equation, and it is so familiar when it comes to the electric field strength, or sorry, I should say the force due to an electric field, and that is just Coulomb's law, which is pretty much the same. Okay. What about the change in potential energy? Well, for gravity, the change in potential energy is UG is mgh. So we've got the mass of the body, we've got the gravitational field strength, and then we've got height above the ground. And of course we know that the change in gravitational potential energy is the same as the work. Work is equal to the change in gravitational potential energy, so that's just that as well. What about electric field? The change in electric potential energy, I should say, QED, I'm not sure if you can see that, right, from the recent video we've just done. So there's different expressions that we can have there for the change in potential energy. Gravitational potential energy, electrical potential energy. The force in a uniform field, well, the gravitational force is just equal to mg, and the electric force was equal to QE. So that's a comparison of all the different features to do with the gravitational field and electric field. We could probably get rid of one of those, but I'll put those in there just to sort of bring it back to your memory and to sort of make sense. And you can see that there are equivalents here, right? Mass, charge, field, field, and H and D are both distance anyway, okay? So make sure you get those down. You can explain those formulas. They sort of make sense to you. Draw it all out. Maybe put the table up, put them in different colors, because there's a lot of concepts here that need to be in your head. Okay, see you next video.